Children, now we are going to learn about group 13, that is boron group elements. From this we are going to learn about boron. Group 13 elements: boron, aluminium, gallium, indium, thallium, then the radioactive element Na, nihonium. Among these, boron is a non-metal, less reactive. We are going to learn only about boron. Boron occurs mostly as borates. Then the important O's are: number 1, borax; formula Na2B4O5 OH 4 times 8H2O. Then number 2, kernite. This also can be written as Na2B4O7 10H2O, borax. Next, number 2, kernite, Na2B4O5 OH 4 times 2H2O. These two are the O's of boron. Then aluminium. Regarding aluminium, it is the most abundant metal and occurs as oxides, and also it is found in aluminosilicate rocks. Then commercially it is prepared from the ore bauxite. Formula Al2O3 2H2O. Already have learnt in lesson number 1. Then the other elements only found in trace amounts: gallium, indium, thallium. They are also occur as sulfides. Boron is the only non-metal, less reactive, but react at high temperature. So it has electron deficient. So unusual covalent bonding. Reason is, one is due to small size, then high ionization energy, high electronegativity. The electronegativity is similar to carbon and hydrogen. Some of the chemical properties now we are going to learn. Boron is the only non-metal, so it is less reactive, but react at very high temperature. Its compounds are electron deficient and has unusual covalent bonding due to small size, high ionization energy, and electronegativity is similar to carbon and hydrogen. Based upon this, some of the chemical properties, the headings are given here. Number 1, formation of metal borides, reaction of boron trihalides, formation of hydrides, formation of boron trihalides, formation of boron nitride, formation of oxides, reaction with acids and alkalis. First one, with metal. Boron react with metals except alkali metal, forming the formula MXBY. Here X is equal to 11, Y is equal to 66 or higher compounds. Now for example, chromium combined with boron, a metal, forming at a high temperature, that is 1500 degrees Celsius. See, chromium combines with boron and forming at high temperature it forms a compound. The next second one is reduction of boron trihalides. Number 2, reduction of boron trihalides, that is boron trichloride with tungsten, W means tungsten, at 1500 Kelvin forming tungsten boride plus chlorine plus HCl. Tungsten boride. This is chromium boride. Next, number 3, formation of hydrides. Boron does not react with hydrogen, does not react directly with hydrogen. However, it forms a variety of hydrides called boranes. The simplest boron is diborane, formula B2H6. Larger boranes are also prepared from B2H6 only. Treatment of boron trifluoride in vapor phase with sodium hydride at 450 Kelvin forming diborane B2H6 plus NaF. Balancing, here 6, here 6, here 2, here 2. See, this diborane at once formed can be removed in order to prevent from pyrolysis or decomposition. Next, formation of boron trihalide. Boron trihalide. Boron combining with halogens. Generally, I can write as X, X2, chlorine, bromine, iodine or fluorine, forming boron trihalide BX3 on heating. Balancing, 2 boron, 3 halogen forming 2 boron trihalide. Next, formation of boron nitride. Boron burns with nitrogen at high temperature to forming boron nitride. Balancing. Next, formation of oxides. Boron treated with oxygen at 900 Kelvin forming boron trioxide B2O3. Balancing. Next, formation of oxides over. Next, treated with acids. Boron does not react with halo acids like Hi, HCl, HF, HBr. It will not react. But it reacts with oxidizing acids such as sulfuric acid, nitric acid. That is boron with the sulfuric acid H2SO4 giving boric acid H3BO3 plus SO2 gas evolved. Balancing, 2B, 3H2SO4, 2H3BO3. Then boron with nitric acid HNO3 forming boric acid H3BO3 plus nitrogen dioxide. Balancing, 3HNO3, 3NO2, nitric acid. Then next, boron reacts with sodium hydroxide. Boron reacts with an alkali, sodium hydroxide, forming sodium borate Na3BO3 plus hydrogen gas is evolved. 3 hydrogen. Sodium borate, sodium borate. These are the chemical properties of boron. All the reactions you have to learn. It is clearly given in a book, page number 32 and 33. Then uses of boron. Boron has the capacity to absorb neutrons. Hence its isotope B5, 10B5 is used as moderator in nuclear reactors. Number 1, it is used as a moderator in nuclear reactors. Number 2, amorphous boron is used as a rocket fuel igniter. Then boron is essential for the cell wall of plants. Then compounds of boron have many applications. For example, eye drops, antiseptic, washing powder, these are all contains boric acid, borax, in the manufacture of Pyrex glass. Pyrex glass, boric oxide is used. These are the uses of boron. Everything clearly given in book page number 32 and 33. All the reactions you have to write in your note and you have to go through in the book also. PDF already I have sent for your children. So go through the book also and prepare all the reactions and you write it in the classwork note.